Welcome, I'm Kevin King. In this, the second of our series of 6 training videos, I will introduce our Intro guidance system hardware and some of the hardware options that are available. We will start by looking at the system as a whole. This slide depicts a standard single section system with some of the standard options. At its core is the implement module to which all peripheral devices are connected. Connected devices include position sensors, for example to measure side shift position and in-work status, odometer wheels, which is one of several options for measuring speed, and valves for the control of hydraulic cylinders. We use 2 types of data connection. The first is based on gigabit Ethernet for high-speed data. It connects the console and cameras to the module. Cameras are low-power devices, so can derive their power using power over Ethernet. One camera is all that is needed for many applications, but a second socket is fitted as standard, making a second camera simple to fit. For applications with more than 2 cameras, additional sockets can be fitted by special request. The console, which incorporates a fairly powerful computer, is connected via an Ethernet cable that also includes some power cores. The second data connection is based on CAN bus, which we use to connect a variety of our own peripheral devices. For inter-row applications, these are most commonly manual or feeler override boxes, but for our more advanced applications, not covered in this series of presentations, they can include control for within-row cultivators, spray nozzles, and condition monitoring. So the system is designed to be easy to maintain, and its modular, flexible nature allows many different configurations to be built up using standard parts. For example, if you wish to control 2 implement sections from a single console, you can plug in a second module to control an additional section. All parts are the same, except the implement modules are modified slightly to make master and slave versions. Again, we use point-to-point cabling to cater for all machine sizes and to make service simpler. An optional anti-clash input prevents the sections from colliding. Dual section systems facilitate higher working rates and are becoming more popular. Similarly, you can follow 3 independently planted belts with a triple system. This uses a master module with 2 slaves. The 3 sections can all be rear mounted, all front mounted, or split with the centre section on the front and the outer sections on the rear of the tractor. This is a particularly nice configuration from a vision guidance perspective, as it gives a totally clear view for all 3 cameras, thus providing the best possible performance. Let's take a closer look at some of these components individually now. Starting with the console, it has a 9-inch colour touchscreen, behind which sits a small but very powerful PC, running our image analysis and plant tracking software. It is housed in a machined aluminium case, with sockets for connection to the implement module and a USB stick through which software can be updated or data exchanged. There is also a power button. All of these components are sealed to the case, which is showerproof but is intended for mounted within a tractor cab. The VESA mounting holes at the back will accommodate a variety of mounting arrangements, but we recommend RAM mounts or similar as they are convenient and provide a degree of vibration isolation. The camera is mounted within an aluminium casing with O-ring seals specifically designed for the agricultural environment. However, they will not withstand pressure washing, and it's prudent to store them undercover, especially during the winter. There are no user serviceable parts inside, and it's important that the seals are not broken, as moisture ingress will lead to misting inside the camera glass cover and will degrade the electronic parts inside. We offer our cameras with 2 lens options, 6mm as standard for normal inter-row applications, and a wider angle 4mm lens for special applications, where the camera cannot be mounted sufficiently high to get the required field of view. The lens type is shown on the label, but lens data is programmed into the camera so that it can be automatically recognised by our system and the correct parameters used. The camera has 2 M6 mounting holes machined either side of the case. We also offer a camera bracket, which offers a convenient way of adjusting the camera inclination. The implement module is nominally waterproof, but is sealed to a lower standard than the cameras. so we recommend that it is housed under a covering that protects it from direct rain or cleaning jets. System 12 volt power comes into the module on a flying short lead with a 2-pin connector. An LED power indicator provides system status information via blink code. On power up, it's continuously on for a few seconds before going into a slow 1.5 second blink, indicating it is running but idle. Once the working screen is displayed, the blinks speed up to a very rapid but even blink. Other blink patterns are associated with error codes that are listed in the reference manual. The module has a number of sockets as previously described for connection to the console, camera, CAN bus, valve connections, lift, position, and odometry sensor cables are colour coded. The external label provides a graphical description of connector functions. There is also an internal lid label providing more information on internal connections and settings, though it's not normally necessary to remove that lid. Most cables have connectors at both ends, so it can be easily swapped out in the event of damage. They are also available in a range of lengths, making installations neater and safer. Here we have a camera cable, a console cable, and a power cable. Our system can accommodate a wide range of sensors for measuring linear or rotary movement, as well as proximity detectors or switches. We also stock compatible sensors ourselves for those who want to purchase a complete package. We are also happy to work with customers who provide their own sensors, though it's prudent to check with us for compatibility. For example, we can interface with most position sensors fitted within hydraulic cylinders. Where customers wish to supply their own sensors, we can in most cases provide compatible cables. As an alternative to using your own sensors to detect lift or measure speed, we also offer to connect those module inputs to a tractor 7-pin ISO 11786 socket. That is often a very neat solution, but not all tractors have this socket available. Almost all of our systems are used in applications requiring the control of hydraulic valves. In most cases, these are on-off directional valves that require some sort of additional flow control mechanism to preset the rate of movement. We also support proportional valves that control both the direction and the rate of movement, though at the cost of tighter oil quality requirements and at a higher purchase cost. Customers are welcome to provide their own hydraulic circuits customised to their own needs, but we do offer generic valve blocks incorporating flow control, proportional and non-proportional, that are suitable for most applications. The valve output socket also includes an additional configurable output. Standard valve looms leave that additional output unconnected, but on request, looms can be provided with it included. By default, the output is set to be off, 0 volts, when stationary, and on, 12 volts, when moving. This can be useful in bland spraying applications, for example. Alternatively, that output can be configured to operate night working lights that can be switched on and off from the working screen. These options are available as standard and can be implemented for the cost of the additional components. As mentioned earlier, we communicate between some auxiliary devices and the main implement module via our own proprietary CAN bus protocol. These devices are automatically detected and will be available for use during normal running. The manual control box, when switched to manual, allows a user, a driver, or a second operator to manually steer the implement. Switching it off returns to automatic guidance. The feeler guidance box is electrically very similar to the manual box, except that it receives inputs from proximity detectors. These should be positioned to detect the movement of feelers or whiskers that are set up within the canopy so that they are deflected when the implement is out of position. Its exact behaviour is configurable. Okay, so that has been a quick run through of our Intro guidance system hardware. We pride ourselves on the flexibility of our system. It is modular and designed with robustness and serviceability in mind. Point-to-point cables provide neat serviceable installations. We offer a wide range of sensing options, and can control a wide range of outputs. Our canvas for auxiliary functions adds to our capabilities. An ability to add cameras in an affordable way and operate multi-section machines further enhances performance potential. Our tried and tested touchscreen interface is simple to use and now widely accepted by operators around the world. We hope that you found this presentation useful. Remember that it's part of a series of 6 videos that you can select from our website and view them as many times as you want.
Our website also has links to other reference and training material, including full reference manuals in English, French, Spanish and German. If you have any questions, please get in touch. Thanks for watching.